All right, in this video, we'll look at a couple things. These first questions, we're looking for the domain of these expressions. In other words, what are values of x that are okay and which are not okay? Okay, and then we'll look at some simplifying. So in this first question, and really the thing of the domain for a rational expression, ones that have fractions in them, we're looking at if you have a fraction, if you have, say, 3 over 0, that's not allowed. You cannot, there's no dividing by 0. You're not supposed to do that. And so what we're looking for when we say the domain is what are all the numbers that will work and what are probably the one, maybe two numbers that won't work. There might be more than that, but typically it's one or two with the questions we deal with. So in here, what I'm looking for is what number, when I plug it in for x, will that make the denominator equal to 0? And really what you can do is just take that whole denominator and say, well, 2x cannot be equal to 0. And then solve that equation. It's sort of funny to have a not equal. If you want to think of it as just being an equal sign, you can. And then you want to solve that for x, so I'll divide this side by 2, divide this side by 2. So x is equal to 0. In other words, the number that I do not want to put in for x there is 0 because it'll make the whole expression undefined. It's something that we can't work with. So if they say, for what values is this expression not defined, in this case, it would be 0. You can't put a 0 in for x. In this next one, similar kind of thing. I can just say, well, 2 plus 5, 2y plus 5 is equal to 0. Subtract 5 from both sides, and then divide both sides by 2. So in this case here, you can plug in any value you want for y. Plug in anything, it just cannot be equal to that. Because if I put this in, then that expression on the bottom becomes 0, and you can't have that. Okay, so the domain is any value for y, you can plug anything you want in, just don't plug that in. Now, having said that, now we can look at some other expressions and just sort of manipulate them a little bit. For this first one, what they're really saying is that I can multiply any expression by the same thing, like 4x on the top, 4x on the bottom, and it doesn't change the expression. I can rewrite this in lots of different ways. I could, cancel these out and just call it 3x squared over 5y. I could do that. Or instead of canceling those out, I could multiply them. So on the top, I could get 4x times 3x squared over 4x times 5y. So I could leave it like that. Or I could multiply it through. 4 times 3 is 12. X times x squared is x cubed. Over, on the bottom, 4 times 5 is 20. X times y would just be xy. So I could rewrite this in lots of different ways. I think in the book they probably just want this just to show that you can multiply them. But you could go and you could do rewrite it like this. We'll do this. This is really, in this example, it's going backwards because really the simplest form of this would just be that. But we do this, we multiply it by the same thing. Sometimes if we're adding and subtracting expressions and I need to get a common denominator, often I have to do this kind of thing. All right, in the next example, we're supposed to simplify this. Now, I'd like to just go cancel the a squared like that, but because they are in an expression on the top there, I can't get at them. So I can't cancel those like that. Nor can I cancel the a's. I can't do that. And I can't, like 21 and 28, 7 will go into both of those. I'd love to be able to cancel that, but I can't do that. Can't do that. But if I wanted to, it's sort of like if I had, say, 25 divided by 15. Trying to cancel the a squareds out like that is sort of like just canceling the two 5's there, and you'd be left with 2 over 1. And we know that that's not correct. So you can't do that because that 5 is tied to the 2. It's 25. It's not 2 times 5. Now, having said that, if I can take this expression, well, let's maybe do this 25 one over here first. If I can take any expression like 25 over 15, and if I can rewrite it as a product of factors, like 25 is the same as 5 times 5, and 15 is 5 times 3, then that's the same as 5 over 5 times 5 over 3. But 5 over 5 is equal to 1, right? And so really, 25 over 15 is the same thing as 5 over 3. I can do that same thing over here. And what I need to do is I need to factor these. So if I factor that top expression, I'll have an a here and an a here. Two things that multiply to 21 and add to 10. 7 and 3. 7 and 3. Since this is positive, they both have to be the same sign, and they both have to be negative. Good. Okay. Next one, I know it's going to be an A and an A. I also know because this is positive, the signs have to be the same, and they have to be negative. So two things that multiply to 28 and add to 11, 4 and 7. Now I take a look and I see that there are two factors identical on the top and the bottom. So really I can write this as a minus 3 over a minus 4 times a minus 7 over a minus 7. And like I did right over here, 5 over 5 is the same thing as 1. A minus 7 over a minus 7 is equal to 1. So I could write this as times 1. And when you multiply by 1, it doesn't change anything. So I can leave my final answer as a minus 3 over a minus 4. Probably you wouldn't do a lot of this work here. You would probably just look at this and cross those out because they're the same and write down that as your answer. You might just go right to that step. But this is sort of trying to explain what we're doing. Hopefully that helps you with those questions.